full text is its own beast. You have to create in your database a full text catalog, and that catalog contains full text indexes. But basically, what it allows you to do is to search text more efficiently than not having it. One thing it's also good at, it allows for indexing of these large types. You can't index a varchar max field traditionally. You have to do a full text index. It's worth noting that basically what it does is it takes all the words in your field and separates them out into tokens. And then you can search based upon the individual word from the beginning of the word. So if it had me in there, it had Richard Benner, SQL Solutions Group, 5 separate words. I could search for solutions. I could search for SOL and a wildcard, and it would find it. I could search for GRO and a wildcard, it would find it. What I couldn't do is search for ARD, which is the end of my first name with a wildcard. It just won't search for it. You have to search for the beginning of the word. They're very easy to have problems with. Most of the things I've seen with full text indexes is when there's problems and it's corruption, but that can be dealt with. But if you must do a search based upon a large object type, so the text varchars, image, file binaries on the screen there, then you'll have to consider full text indexes. It's worth noting it does take some time when new data is inserted for it to get indexed, so it's an asynchronous update. So if I insert some data into that table with the full text index and then instantly try to search it, it's not going to be there. It's asynchronous depending on your workloads and the spare resources of SQL Server. So that's something to think about as well. It's not always 100% up to date, but it doesn't need to be in a lot of situations. And again, full text indexes, most of these indexes I could talk about for hours. But if you come across something weird, if you're applying these, reach out, just let us know. Other things to consider with an index. I've mentioned about memory. And what happens when you read these data, just to go over it briefly again, when you read these indexes, it will be, you're reading in that data into memory. You only have X amount of memory on your server. Let's say you've got 100 gig of memory. If you're loading in a lot of 5 gig indexes, they're all going to get loaded into memory. They will persist in memory until your memory is full, and then SQL Server tries to pull in more data, at which point it will take your oldest pages of memory and send them back to disk. Reading from memory is fast. Reading from disk is relatively slow. So you want to have as much relevant data in memory as possible to see the best performance improvements. If you've got a lot of big indexes, a lot of poorly designed indexes, you could be cycling data into memory and out of memory quite quickly. You may have heard of page life expectancy as a statistic in SQL Server. That is the amount of seconds that SQL Server expects itself to be able to hold data in memory before it has to flush it back to disk. So you want to be efficient with how you're using it. It's also worth noting, for every statistic you create, there isn't, and you don't have the setting of auto create statistics disabled. It's on by default. As long as you haven't turned that off, then every index will get a statistic behind it. And what this is, SQL Server samples the data that's in the table and creates a histogram, which is like a horizontal bar graph, which will help itself understand where the data is, how your data is laid out. If you've got much more data of a certain type in there, it'll know. Statistics is what SQL Server uses when it decides to create an execution plan and when it's trying to work out the best way of executing a query and returning the results to you. There's some problems with this. So statistics, there is an auto update statistics setting in SQL Server, which will be on unless you've turned it off for some reason. Statistics get created when you create an index or rebuild an index. It will refresh the statistics. Alternatively, when you hit a threshold, which is, I believe, 10% of data that's changed, SQL Server will rebuild your statistics. Between those 2 points, SQL Server doesn't have a histogram or any information about how your index has been created. Sorry, not how your index has been created, how your data is laid out within that index. That's accentuated perfectly by the ascending key problem. So what that is, imagine you have a table with an identity column as the first column, or as any column, which is an int value that increases by 1. When you insert a row of data, it increments by 1. So I've got a million rows of data in my table. I rebuild the index or create the index. SQL Server takes those million rows and it knows the layout of the data, where the data is, how much data is in there, what types of data you have. I then insert, I spend 2 months inserting data. I insert another 5,000 rows, 10,000 rows, whatever. Anything up to 100,000 rows will get inserted, but the statistics won't get updated for those. So I'm inserting, let's say, order data again. I'm inserting data into the table about my orders, and I'm updating it, and then I'm querying that data. But SQL Server doesn't know the layout of that data because it hasn't updated its statistics. So it can make terrible decisions on how it's going to return that data to you. We'll talk about maintenance later, but basically you want to be a bit more proactive in the updating of those statistics so that you can get the best execution plans that you can. One thing I briefly mentioned was the use of indexed and included columns. Now, if you're querying on reputation greater than 10,000 and then returning multiple fields, including, let's say, a varchar max field, notes, or a question ID, you're joining to another table. You've got two choices here. You could create an index on reputation and include all the other fields. What that's going to do is increase the size of your data, your index, which increases the size of storage on disk, the extra work your IO subsystem is going to have to do, the extra memory is going to be stored. If not every query is using these other columns, these extra data, you need to decide whether you should include that or not. If you don't, you'll often see a thing called a key lookup or a RID lookup, a row ID lookup. And what that means is, it's not necessarily a bad thing, but what it'll do is, I'm only going to index reputation greater than 10,000. Now, one thing to know, in any non-clustered index, if there's a primary key on the table, that is included in your index. It's hidden in the background. It's there. So what it'll do, what I'm doing is I'm querying for users with greater than 10,000 reputation. And then I want to know their name, their user ID, their account ID, their country, any other fields. If that's not included in my index, what SQL Server will do is go and look at my index. It'll search down for John Skeet, and then it'll do a key lookup. It'll take the primary key of the table and go and take that and loop around and return the data it needs. It'll have to hit the clustered index again, or the heap table again, to return the extra data. Now, when you have a key lookup, each of those additional fetches is effectively 3 times as expensive. It takes 3 data pages as a rough estimate, which, if you're doing that a lot, if you're doing key lookups on 1 million rows, that sucks. If your table's 1 million rows, but you're only searching for 4 rows and doing key lookups, maybe you go for that. A lot of the indexing stuff that we'll talk about and we will talk about next is an art more than a science. But it's a case of trial and error and working your way through it and seeing what works best in your environment.